of your notes, and here we're looking for, how do I know if it's a solution to the equation? So I could look at it by graphing it. So graphically, when I graph my equation, so you guys had created tables in our previous notes. We chose our x values and we plugged them into this equation here and found our y values. So this is 1, this would be 2, this would be 1, -1, and this is -2. And as I plot them, I know each of these are solutions to this equation. I also know if I notice here, I should have 2, -1, which is here. These points here, and it's really small. These here, because it falls on the line, these are all solutions to this equation. So graphically, I could just look at my line, and whichever point lies on that line is a solution to that graph. But what if I don't create a table and I don't graph it? I could check if it is algebraically. We've had some experience with this, and now I'm formalizing this. So I'm looking at, is the point on the line? So I'm checking to see, is this point on this line if I were to graph it? So algebraically, I'm just going to substitute my values. So here I'm going to substitute my values. When I look at a coordinate system, my ordered pair, this is my x value and this is my y value. So that's my x and that's my y value. And when I plug them in, if it's a true statement, then yes, it is. If it's a false statement, then it's not a solution. Okay, we've been familiar with that as well. So here I'm checking if 2, 10, which is an ordered pair. The order matters. My first one is my x value and my second one is my y value. So I'm going to replace my letters with numbers. So when I'm going to use, here's my y equals 4 times my x number plus 2, and my y we said was 10, so I'm going to write 10 here. And here it's 4 times my x number, which is 2. I'm going to plug in 2 there. And I'm going to solve one side at a time. The left is already simplified. My right, using order of operations, 4 times 2 is 10. 8 plus 2 is 10. And my answer is 10. And this side is 10. It's true. So yes, this is a solution. Yes, 210 is a solution. Okay, so that's how I would show it algebraically. Now let's look at this one. This is my x value. This is my y value. I'm going to kind of color code it. This is x, and here's y. And every time I see my x, here, let's see, y we said was green, and x is blue. So I'm replacing them. So here's my y value, and I get -6 times my x number plus 7. So I'm just going to replace each letter with its corresponding value. So y is, I'm going to make that green, -5, green, -5. And my x number, which is blue, is -6 times my x number. Now using order of operations. -18, that gives me 18 plus 7, and I get 25, and the other side is already simplified, and I have -5, so it is false. This is not true, so it is not a solution. Okay, so now I'm just plugging my values in to see if it is a true statement. And here we have, this is my x, and that's my y. So here I'm going to, what did I do? Y is green. So y, I'm making that green, and x, I'm making that blue. So I have 3 times my x number minus 2 times my y number, and I want to know if that equals 2. So 3 times my x number, which is 4, 2 times my y number, which is 1. Using order of operations, I'm going to simplify my left side. 3 times 4 4 is 12. And I'm going to write that step just to show that how I'm getting these answers. 2 minus 1 is 2. And 12 minus 2 is 10. So on the other side, it's already simplified. And that is 2. And this is not a true statement, so no, not a solution. So that point does not fall on that graph. Okay, so that's how I know algebraically. Just making sure I do that right. Okay, didn't drop a negative or anything. Okay, here I have an X and a Y. I'm making my X is blue and my Y is green, just to show you what I'm substituting. And 3 times my X number minus 2 times my Y number, and the other side is 19. So I'm plugging in -3 for X. I'm plugging in 5 for Y, and I have -9. And I have to do this first, minus 10. And negative, these are both negative, so I'm adding them, and I get -19. It does equal the other side, so yes, it is a solution. -3, 5 is a solution. Okay. In other words, if I were to graph this equation, this point will be on that line. Okay. Or if I would create a t-table, that point would be part of my t-table. That's it.